All right, so this is AP Calculus Worksheet 8-2. This is the key, the solutions. All right, so the main thing that we know is that if I take the integral of the rate, f prime, or the rate like that, I get the total change. That's what it means for total change. In fact, I need to be adding that to our speed sheet and make that for the warm-up tomorrow. All right, again, these aren't really labeled that well. This is going to be number one, the rate at which we have things flowing out of a pipe. I'm going to underline the word out because that means I have a negative rate. Oh, I don't have two rates. I don't have to worry about negative. I have to just explain the meaning of this thing. So because this is a unit of total change, I'm going to use the words total change in here. Let me come down here and make this slightly smaller. So that thing means the total change in, I guess I'll say in parentheses here, in gallons per hour. Oh, so total change in just gallons, right? It's not a rate. Total change in gallons from 0 to 24 hours. Done. Next one. Explain the meaning of this thing. So this is also going to be total change because I'm taking the integral of a rate. This is the total change in what? In degrees Celsius in this case. It's always whatever that unit is for the amount. Total degree change in, I don't have the ability to type in a, does anyone know the shortcut key for degrees in a Mac? Is it?
Control H.
Ah!
Yeah.
Option 0.
Yeah. I knew it had something to do with
Degrees
0.
Celsius.
Done it before.
I'll put that in parentheses. In degrees Celsius, from where to where? From 0 to 8. 0 to 8 centimeters in this case. Yeah, because we're integrating from 0 to 8 centimeters. You can see here 0 to 8 centimeters. Kind of a weird thing because it's not time, but there it is. And then how many cubic feet of snow have accumulated on the driveway at 6 a.m.? So now we have a function. This is I guess I should be putting a calculator problem over here. I haven't even been labeling these. This was 2, this is number 3. So number 3 is our first calculator problem. Let's come over here and get rid of all that stuff from our notes. I'm gonna have to plug all these in. Clear, down, clear, come up. Oop. And my function is 7x second natural log to e to the power of cosine of x. All right, I have all my function in there. I can end the parentheses yet again if I need to. I don't really need to. And how many feet have accumulated? So I'm taking the integral of whatever this thing is. So I'm going to do math 9, vars right, enter, y1 with respect to x from, by 6 a.m. I assume you start at, from midnight, perfect. So from midnight to 6 a.m. So from 0 to 6. And I'll let that do its thing, but I'm really doing the integral from 0 to 6 of our f of t dt. All right, and that is given by 142.274. I said 42, right? 42.274. 274. What are our units? Cubic feet. So we'll say feet cubed. It's not feet cubed per hour because it was a rate, but when you integrate rate, you're just left with units that have no time in it. Number 4. We have another equation. Let's go ahead and plug that into our calculator as well. Clear out of view. I now have, move you to the side, 100x squared sine of square root of x. Cool, I'm not going to end parentheses, I'm too lazy. And I have the function correct, and between 0 and 7, that's good. How many gallons enter the tank? So this is going to be, again, I'm looking for the integral between 0 and 7 of that f of t dt. And on our calculator, again, math 9, getting pretty repetitive, vars right, enter, y1 with respect to x from 0 to 7, and I get, what did I do? Go to y1 with respect to x. Why is it giving me an error here? It's my y1. Oh, I did y2 instead of y1. Oops. So I come back here. I can just replace that with y2. Vars right, enter 2. And now that'll work. And go. Calculate. Waiting. Oh man, this must be kind of a fun function. Okay, 8,263. 8,263.807. 807. What are our units? It doesn't say units indicate units. It really should, because that's what, oh, no, it doesn't, okay. And it's in gallons per hour, so get rid of the units, and it's just in gallons. Gallons, all right. Number 5. Maybe that should be added to the speed sheet too. Cross off the, whenever you're looking for total change, then you just cross off your time, because it's always going to be non-time units. Number 5, underground tank is leaking, so it's the negative rate for 0 to 120. How many leak from 0 to 3 minutes? So what is the integral from 0 to 3 of that function, which is square root of t plus 1 dt. All right, so I can just plug that in directly, so I can do math 9, and then I can just type this in directly. Second square root of t plus 1, and the square root. This can be with respect from x, with respect to x, from 0 to 3. All right, 4.6 repeating. 4.667 rounding correctly. Our units are gallons. You get rid of the time, so it's just gallons. And there's our final answer. Number 6. All right, water is leaking from a swimming pool. There's our function. Probably going to need that. Let's come over here to our, let's enter it in y1 correctly this time. It's going to be 25-second natural log to get e to the power of negative 0.05x. And it looks good. Okay, we have our function. Let's get rid of that. We don't need you anymore. Calculate the total amount of water leaked between 0 and 12. So I'm just going to do integral between 0 and 12. And this is going to be capital R of t dt. So I'm going to come over here and do math 9 to the integral of var's right, enter 1 with respect to x from 0 to 12. Hit enter, it's going to do its thing, 225.594. 225 point, what was it, 594? 594. Our units cross off the hours, it's just cubic feet, or feet to the power of 3. Feet cubed. Perfect, that was number 6. And number 7, I have this graph. And it's modeled by the function f above. So between 4 and 24, it's piecewise linear, which means that those are all lines. So for this function right there, I don't know what's happening, but I don't care because it's not asking about this. It's only asking between 6 and 18. So total number of calories. Whenever you see the word total number, or total, I guess I should say, you should be thinking, what is the integral? And another way of thinking of integral is, what is the area between 6 and 18? So where's 6? 6 is right there. Maybe we should make that a straight line. So 6 is right there, and 18 is right there. So kind of weird shapes going on, but we got this. So the way that I divide this up is I can see a rectangle there, a triangle and a rectangle there, and let's add that all up. So this rectangle, again, this is going from 6 to 18. So 18 minus 6 is 12, so that has a unit distance down here of 12. I'll write that down here, 12, and then the height here is 9. 12 times 9, 12 and 9, that's 8. Carry the 1, 108. So this has an area of 108. And this triangle, it goes from 12 to 16 right there, right? So 12 to 16, that means I'm going up 4, so this distance is 4 here. And then the height goes from 9 to 15, from 9 to 15, so the height is 6. So 4 times 6 is 24, and then half of 24 is 12. That has an area of 12, area of 108. And then finally this rectangle goes from 16 to 18, so it's 2, again by 6. 2 times 6 is, oh, another 12. It's interesting that those both have the same exact area. Probably not drawn to scale, or maybe it is, and I'm just not seeing it correctly. So add them all up. And how do we write out our work? We say, yes, we were trying to find the integral between, not 0, but 6 and 18 of that function, which doesn't really have a name, function f. So f dt, y dt, because there's a t right there, and that is equal to 108 plus 12 plus 12. So 108 plus 12 is 120, so 132. 132, what are our units? Well, it was calories per minute. Get rid of the per minute, and you just are left with calories. So CAL for calories. And then we're on to number 8. Is that our final? Oh, well, this is a packet. That's right. So number 8, we have lots of these problems. I'm looking for the number of people that arrive. So how many? That's kind of a total amount question between 0 and 3. So the integral between 0 and 3 of this r of t function, lowercase r of t dt. So whenever I'm thinking of integral, I'm always thinking of area between 0 and 3. So let's come over here and make a line between 3 and 0. So all of this area right there, what is that? What is all that area? So let's split this up into shapes that look nice. So I have a rectangle right there. I have a triangle there, a triangle there. So I have 2 triangles. I have a rectangle and a rectangle. That's the 4 shapes that I've decided upon. So between 0 and 2, that's a distance of 2. That's a height of 1,000. So that's clearly 2,000. You multiply them. This is a base of 2, a height of 200. 2 times 200 is 400, and then take half of that. That's 200. So let me circle these. Ooh, circle that one. This is 200 for that area. These are congruent triangles, so I think they're probably going to be the same. Let's just double check. 800 to 1200 is 400. 400 times 1 is 400. Half of that is, again, 200. Perfect. They were congruent triangles. That makes sense. And finally, this rectangle is 1 by 800. 1 times 800 is 800. Add them all up. So if I add, I'll show my work, 2,000 plus 200 plus 200 plus 800. Well, I know that those two are 1,000, and then that is going to be 3,000, so 3,200. So 3,200 what? Shows rate at which people arrive throughout the day. So it's people per hour or something like that, because it's people per hour. So get rid of the hours and you're just left with people. It also tells you that in the question, doesn't it? How many people? That's our units.
No, what's the calculator command so you can go into the previous problem?
Previous problem, if you want to retype that line, second enter, that's the second to do the entry. Yeah, good question. Number 9. Oh, we have a positive and negative rate. So pumped into, that's a positive rate. And removed, that's a negative rate. So let's punch these both into our calculator. Maybe the punch is an inappropriate word. Let's type them politely into our calculators. 2 plus 10 divided by, in parentheses, 1 plus natural log of x plus 1. I'm not going to end parentheses, too much work. And then this one is going to be 12 sine of x squared divided by 47. Again, there needs to be a division symbol in here. So second delete to insert the division symbol. And that looks good. All right, so let's get out of that, clear out of view. And what is the question actually asking? So how many gallons are pumped into? So this is only asking the positive rate. If it's asking into, it's asking the integral of the h, capital H of t, the positive rate, dt. From where to where? From 0 to 12. From 0 to 12. So I come back up here. That was my y1 function. I guess I should really do my y3 function. I'll know I'll need him. Positive rate minus negative rate, so y1 minus y2, var's right. Enter 1 minus var's right. Enter 2. I have that one programmed in. So I'm really talking about my y1 function. So I'm going to do math 9 of my var's right. Enter 1, my y1 function with respect to x from 0 to 12. Enter. And we'll get an answer here. 70.57. 70.570, right? 571. And then what are our units? And it already tells you it's gallons. Next one, I'm probably going to be doing an integral. Yes, because it's talking about how many. If it's ever asking the question how many, it's always going to be the integral between 0 and 12 again, 0 and 12, and are removed. So this is the negative rate. So this is the capital R of t function. dt, that's my y2 function, so I'm just going to hit second enter, scroll, hover over the y1 and hit var's right, enter 2 to replace that with y2. Hit enter, saves you a bit of time. 73.545 equals to 73.545 units here are still gallons. And then finally, the total change So total change is going to be that h of t minus r of t, or the y1 minus the y2 function, again from 0 to 12, so 0 to 12. That's going to be capital H of t minus capital R of t, all of that thing multiplied by dt, which is a fancy way of saying my y3 function. So I'm going to second enter again, second enter to hover over my y2 function. Var is right, enter 3 to replace that with y3, hit enter, and I should get a negative because 70 minus 73 is like negative 2.9 something, I'm going to guess. What do we got? Oh, it's negative 3 point something, isn't it? Oh, no, negative 2.974. Negative 2.974. Our units are still gallons because you're doing gallons minus gallons to get gallons. All right, that was question number 9. We are on to question number 10. I was about to box it. It's circled. Whoa, what happened there? If I scroll up and down, will it fix it? It does. All right. It's pumped into the water tank at a constant rate of 8 gallons per minute. That means into is a positive rate. So I have a positive rate of 8 gallons per minute. And then leaks out of the tank. So leaks out, that's a negative indicator. So a negative rate of square root of t plus 1. So how much are pumped into the tank? So I'm talking about the positive. So into is the positive word that I'm looking for. So it's talking about the positive 8. So between 0 and 3 minutes. And what is our function? It's just a constant 8. Constant literally means the number. So just 8 dt. So how do I do this? You can use a shortcut, which is you do top minus bottom. So 3 minus 0, and then I multiply by whatever the constant number is, 8. And 3 times 8 is 24. What are our units? How many gallons? So 24 gallons. Next question. How many gallons leak out? So now I'm going to do the integration from 0 to 3 of our negative rate. Our negative rate was the square root of t plus 1. Square root of t plus 1 dt. This one I'm going to need a calculator for, so actually I don't need to enter it in there. I can just go like this. I can do math 9, the integration of second square root of t plus 1 and parentheses. Okay, that's going to be with respect to x from 0 to 3. And have we done this problem before? 4.6 repeating. This seems very familiar. 4.667 gallons. And then what is the total change? You subtract the 2. So what is 24 minus your answer? The way that you type that in your calculator is what is 24 minus second, this negative symbol to do answer, and you get 19.3 repeating. So technically you're doing the integration between 0 and 3 of your positive 8 rate minus your negative rate, which is the square root of t plus 1, all of that stuff, dt, and that's just a fancy way of saying what is 24 minus 4.667, and the answer is this thing, 19.333. Oops, 19.333 gallons. All right, so this is now number 11. We're selling cable $420 per meter. The cost to produce it is that equation. So if I'm making a profit of $120 a meter because I'm selling it and I'm getting $120, that means that's a positive amount. I'm gaining that. It's a positive rate. And I have to spend money. I have to spend money to produce it at that much, so that's a negative rate. So I'm going to immediately open up my calculator again so I close that. Darn it. File, open recent, TI-3 plus. And plug that into our calculator. I guess I could do it the other way. I don't need to go that way, sorry. How much total income is generated? So I don't care about total profit, which is down here. I'm just, what is going in? What is the positive rate? On a 25 meter cable, well, it's 120 per meter. So I'm going to take the integral between 0 and 25, from 0 meters to 25 meters. And it's going to be 120 fixed cost. So, and it kind of doesn't make sense to do an integral. It kind of makes sense to say, oh yeah, it's $120 per meter and 25 meters, so just multiply the two together. And you would be correct. That is a perfect way of finding it. This is the old-fashioned way of doing it. Dx, and then you could say, okay, well that's 25 minus 0, our shortcut, right? 25 minus 0, all of this times 120. You do the end boundary minus the start boundary times the constant number, or just 25 times 120, which is exactly what I just said. So we have a calculator, so let's use it. 25 times 120, 3,000. So that's going to be net profit, well, not profit, net income of 3, you don't have a comma there, 000, $3,000. How much does it cost to produce? So what is your negative rate of a 25 meter cable? So now I'm doing this one with the same integral from 0 to 25. So integral from 0 to 25 of 6 square root of x dx. And this is where I do need to use a calculator, and I didn't need to use my y equals. I could just do math 9 and type in the function here. It's going to be 6 second squared to do the square root of x, and my parenthesis, comma, with respect to x, comma, from 0, comma, to 25, and enter. And it tells us, did I enter that correctly? I did, okay. It tells us that we will have to spend, my calculator wants to actually spit out an answer here. Whoa, exactly $500, and I mean, like, what was that, 1/1000 of a penny? Yeah, so $500. $500. My units are the money symbol, right? And then the total profit, well, then it's your positive rate minus your negative rate. So it's $3,000 minus your $500. And the formal way of saying that in terms of your integral, it's 0 to 25 of your positive rate. I'm making $3,000, so 120 minus the negative rate, 6 square root of x, all that dx, and that's the same thing as, oh yeah, just take 3,000 and subtract 500, and I think we can all do that in our head. Whoa, that's 5,000. Do that in your head. So that's $2,500 runes. Let's go ahead and move you over here. $2,500. All right. That was number 11. We're on to number 12 now. Water in a storage tank, and it's entering the tank, so that's going to be a positive amount, and it's leaving the tank, so that's going to be a negative amount. And the negative amount is all of this piecewise function, and we're looking for water entering the tank, so it's asking about the positive. Command Shift C, the positive amount on that interval, so between 0 and 7. But notice that for 0 and 3 it's 250, and then from 3 to 7 it's 2,000. Wait, that's leaving the tank. We're talking about the entering the tank. We're just talking about that function. So I'm going to do the integral from 0 to 7 of f of t. So lowercase f of t dt is talking about that function. So I do need to plug you in. And I don't need to plug it into my y equals because I don't have two functions. Like, this is just a constant amount, so it's not really worth doing that. I now have math 9, the integral of 100 x squared times sine of square root of t. I don't know why I'm doing. Oh, I do need the parentheses, so that's ending the parentheses for the sine. I don't need to end parentheses yet, so I'm going to do yes with respect to x from 0 to 7. Oh no, did I miss a parenthesis? 100 x squared sine of. Oh yeah, that was the parenthesis for the square root. This was the parenthesis, the end of the square root. I need a parenthesis that ends the sine. So I'm going to come back over here, hover second, delete to insert another parenthesis, and then hit enter. Now it will work. And it will tell me that this answer is equal to, go calculator, 8,263. 8,263.807. And what is that units? So it's going to be in gallons and like per hour, but we get rid of the hour, right? So it's just gallons. So gallons. How much water leaves the tank? So now I have to go from 0 to 7. I do have to treat this as two different integrals. I have an integral from 0 to 3, and then an integral from 3 to 7 of two different constant amounts. So it's going to be an integral from 0 to the suspect point 3 of 250 dt, and I'm going to add that, the integral from the suspect point 3 to the end boundary of 7, which also is right there too, of 2,000 dt. Okay, so this one is just kind of using some mental math here. This is going to be 3 minus 0 times 250. Again, you do the end minus start times the number plus end minus start, so 7 minus 3 times 2,000. So that's 3 times 250, which is 750. I can switch colors here again. 750. And this is going to be 4 times 2,000, which is 8,000. 8,750 is our final answer. 8,750. And that's in gallons again. That's how much is leaving the tank. So more is leaving the tank than is entering the tank. And then the total change is going to be your positive rate minus your negative rate. How would you write this out? You actually have to write 2 separate integrals. You'd have to do, it's kind of pedantic to actually write this down, but I will write it just in case you want to know. It's going to be the integral from 0 to 3 of the positive rate, so f of t, minus 250. All of that dt, and then I still have to add that to the other one, because this is a change. I'm going to add the other change, and I'll get the total change from 3 to 7 of f of t minus 2,000 dt. So that's a formal way of saying it, which isn't very helpful, because all I'm really doing is I'm saying take your 8,750, well, I'm taking that away from, so I should write this down first, 8,263.807, and then I subtract the negative rate, which is 8,750. Actually, this isn't a rate, this is an amount, the amount that left the tank. So the amount that entered minus the amount that left, that will tell you the total change. And I'm too lazy, I'm sorry, 8,263.807 minus 8,750. Oh, second enter, I forgot a 0. 50. That's negative 486. So this is going to be equal to negative 486.193 gallons. Cool. And I think that's all we have for worksheet 8-2.